Hey everyone, Mr. Pat from the Windward Boys and Girls Club. I'm coming right at you. I'm not going to do a music thing today, so I'm going to start here with a whiteboard on the screen. I just want to do one more problem practice of that very involved formula, the quadratic formula, graphing a quadratic function, and then introduce the next thing we're going to go into, which is equations with square root radicals in them. And also let you know, it looks like, yes, this summer we will probably have some formal Zoom math classes. It'll kind of be like this stuff, but a little more focused. You'll be able to give feedback, so you'll be able to really fill in a lot of blanks if you have any from watching these. Anyhow, we'll keep you informed with that, and should be maybe me and Mr. Tom. We'll see what's going on. We're looking forward to that too. Okay. So this will be our last dedicated day to the quadratic formula. So this formula right here is the one in green that looks very intricate because it is. It requires a quadratic function, which means your x is going to have the second power there. And we've learned a few ways to do that, spread over like 5 or 6 days of instruction. You can always go back and review if you need to. So in order to solve and graph this, find the zeros, all that, we're going to use both of these formulas we use, the quadratic formula and this other little thing. It all begins with your A, B, and C value. Probably the most important thing you can make sure you do right. You want to make sure and get the negatives and positives right. A is the coefficient right there, multiplying times the quadratic. X squared is a 1. The B is the thing multiplying times the x, the linear term. That is not a 6, but a negative 6. You heard me say that kind of thing quite a few times. And C is this value here. They call it a constant. You can think of it just plain old number, no variable attached. So that's positive 4. So we're going to use these formulas and do both of these. We'll do the orange one first. So I'm going to go ahead and do it. So x equals negative, and then I write what b is. So there's negative from the formula, there's the value of b over 2 times a. So the opposite of a negative is a positive, so x equals positive 6 over 2, which equals 3. So far so good. So that formula we use to give us a couple bits of information. So we have x equals 3. So I'm going to erase this right here and put a 3. So for this, we are going to use it right now. We've done that formula quite a few times. Here's what that told us. It told us our axis of symmetry is x equals 3. So we can come over here and 1, 2, 3, positive 3 on the x-axis. This is the line. We always recommend you make it a dotted line so you don't get it confused with the x or y axis. And that's called our axis of symmetry. Okay, that is the middle of the U-shaped graph you're going to make the parabola. Okay, this x equals 3 also gives us the x-coordinate of the vertex. So xy is coordinates of a point. We know our x-coordinate is 3. We don't know what y is yet, so we're going to find out. So what we do is we go to our equation and we put a 3 wherever we see an X, and that will tell us the Y value. So it says Y equals X squared. So we go 3 squared minus 6 times X. So minus 6 times 3 plus 4. So I plug that number wherever I see an X. 3 squared is 3 times 3, which is 9. Minus 6 times 3 plus 4. That's what our Y value will equal when X is 3. Negative 9 plus 4 is negative 5. So that is very useful information. That's our Y coordinate. So the vertex is 3, negative 5. So I go 1, 2, 3, and then I go 1, 2, 3, 4, 5. So that's my vertex. Double check 1, 2, 3, 4, 5. Okay. That's either the bottom or the top of the parabola. You have to do the other stuff to see. Okay, the last order of business that comes from this doesn't come from that. It's just the knowledge that the C value is our y-intercept. So our y-intercept is 4. So what that means is we went through y. When y-intercept x is 0, everything else disappears except that constant. So that now allows me to put a dot on the y-axis, not here, on the y-axis, 1, 2, 3, 4. Since this is the symmetry line, it's balanced. So if there's something 3 units away here, there's something straight across from it, also 3 units away. Okay, we're doing great. So that kind of is almost enough to make a graph, but we want to go further. We're going to actually solve this, find the zeros. So we got all this information. If we weren't working on a small whiteboard, we have that off in the corner. We wouldn't erase it. We'd leave it there. But now we need a place to work, so I am going to erase all this. One thing I'm going to keep is my A, B, and C values. Okay. And now we're going straight into this formula. So now we did the negative b over 2a. Now what we want to do is this. So we're not using this anymore. So x equals negative b. So negative b. B is already negative. That's that sign, that's the b value. Plus or minus the square root of b squared. Be careful here, put it in parentheses. Minus 4 times a times c. Okay, always reminding you, don't forget to put it over 2a. It's probably the most common mistake. So now let's step back and make sure. Negative b, check. B squared, check. 4ac, check. 2a, got it. Okay, I'll shift over here. So x equals, opposite of a negative is positive. Let me erase that, I got too close to my other thing. Opposite of a negative is still positive. a negative 6 times negative 6 is positive 36. Minus 4 times 1 is 4, times 4 more is 16. And do not forget that 2. You can't cancel the 6 and the 2 because of the plus minus going on. So x equals 6 plus or minus the square root of 20, because that's what 36 minus 16 is, over 2. So we're going to estimate. So square root of 16 is 4, square root of 25 is 5. 20 is right there in the middle. We can use, see, it's 4 away from here and 5 away from there. I'm going to use 4.4. So square root of 20 is about 4.4. So this equals 6 plus or minus 4.4 over 2. That's what we're going to work with. Because that radical is that. Okay? So what I'm going to do is I'm going to erase all this. And I'm going to put this up here. So x equals 6 plus 4.4 over 2. And x equals 6 minus 4.4 over 2. So this splits into these two equations. Right? Okay. Alright. So these ball up here, remember 6 is 6.0. I tried to cover all these basic skills. So it's 10.4. It's not 5. You might go add the 6 and this 4 together and get messed up. So x equals 10.4 over 2. If I divide there, I get about 5.2. So that's one of my answers. Okay. Same thought process. 6.0 minus 4.4. And got to borrow 1. Bring the decimal down. That's a 6. 1.6. So 6 is the bigger of the two numbers, so it's positive. So x equals 1.6. That's my other answer. So those are the zeros of the equation. What I should have said that I didn't add in, you're actually, before you start the quadratic formula, you're putting everything, making y equals 0. So the reason that's called the zeros of the equation is you're finding the x-intercepts. And every point on the x-axis, you don't go up, you don't go down, so y equals 0. So these are the solutions, the zeros of this equation. Okay. Now, here's the deal. You can kind of tell if you're right by the way it looks on the graph. So 1.6, here's 1, here's 2, somewhere right there in the middle. It didn't come out very good, did it? Sorry, hunting around for another green. There's 1.6 about. The other one's 5.2. So 1, 2, 3, 4, 5 point. 1, 2, 3, 4. Whoops, what went wrong? Oh! You see what Mr. Kent did wrong? I see it. Yay, I love it when I catch my own mistakes. I want to show you how I knew it was a mistake first. This is great. I like this when it happens to me as a teacher. Check this out. 1, 2, 3, 4, 5.2 would be out here. That's not balanced along that line, so I knew something was wrong. So see how I got 10.4 over 2 and I got that? That's right. So I looked over here, see what I did wrong? I forgot the over 2. Good catch, Mr. Kent. 0.8. So this bugger's in the wrong place. So 0.8 is not quite 1, so it goes to there. Now we're a lot more balanced. So it's a little more than 2 away on the right, a little more than 2 away on the left. Okay, that's called being careless. Even math teachers get like that. It's good that you see it. You saw it earlier, I showed you. I wear all my mistakes on my sleeve so you can learn from them too. You finish this bugger off. And there's your graph. So you use the one formula for the vertex, the axis. That axis comes in handy. It found my mistake for me. Something you can look for in your own work too. You use that formula, and like I probably told you about 20 times and still did it myself, don't forget that bottom part. That's always the easy part, so it's easy to forget. Okay, awesome. So there you go. There's the quadratic formula. There's quadratic functions, if you will. Okay, so I'm going to erase this now. I'm going to show you something real quick. So tomorrow's lesson is kind of familiar. I want to introduce a concept. Equations with radicals. Okay, so here we go. So it's a different kind of equation. I don't think you've done these before, but you have done radicals. They're just square root symbols. So that's called a radical. And you guys all know the square root of 64 is 8, or positive and negative 8. Okay, so I'm going to go over a concept with you, and we're going to put it to use. So here's example 1. The square root of 7 times the square root of 7. So if you have two radicals multiplying, you multiply what's inside. That equals the square root of 49, which happens to be 7. Example number 2. The square root of 10 times the square root of 10. 10 times 10 is 100, doesn't equal 100, equals the square root of 100, which equals 10. Hopefully you're getting a little bit of the picture. Works for variables. Square root of n times the square root of n. N times n is n squared, so it's the square root of n squared, which equals n. So the rule that you're learning, that you're going to use for solving equations next lesson, if you're multiplying a radical times itself, the exact same things, that thing inside the radical is the answer. So radical 7 times radical 7 is 7. Radical 10 times radical 10 is 10. Radical n times radical n is n. Okay. And it gets complicated in this unit. It looks like this. So let's say you had the square root of x plus 5 times the square root of x plus 5. Okay? So what you need to know is this is radical x plus 5 times the exact same thing. The answer is simply going to be x plus 5. So that's super useful. Super duper useful. It's a little bit strange in your brain, but it works every time. Okay? And we're going to use it. And I'll do one real quick one, and then I'll go over it more slowly tomorrow and put that concept to use. So we have problems that look like this. Okay, let's say we had 5 times the square root of x minus 13 equals 17. Lots of different ways to do it. We'll do a bunch of them tomorrow. So I got a radical here. You haven't seen that before. So we want to clear everything out, and we always get rid of what's being added or subtracted first. So we're going to add 13 to both sides. That cancels. That's 30. I bring this down. Still got that square root. So now we're going to do what we've done with variables. This is 5 times it, so to get rid of that 5, I'm going to divide. Okay, that cancels out to 1s. So I have not x, I have the square root of x equals 6. So this is where the way you solve these is you take each side and you don't square root each side, you square each side. So radical x times radical x is x. 6 times 6 is 36, and that's your answer. So you're going to see this whole thing again tomorrow. I'll develop it again a little bit, then I'll show you these, a few different ones. You get practice on that, and then that'll be it. Okay? So I just wanted to show you this real quick. We'll see about music tomorrow, I'm not sure. Just want to get you some solid math today, and there you have it. All right? Shakas from all of us at the Windward Kailua Boys and Girls Club. Thanks for dialing in. Hope you learned something. Mr. Pat signing off. Aloha.